Hi, my name is Balázs Holzer from Budapest, Hungary, and welcome to my course on database management with SQL and MySQL. So first of all, let me tell a few words about myself. I'm from Budapest, Hungary, as I said earlier. I'm working as a software engineer at a multinational company. I'm qualified as a physicist, and later on I decided to get a master's degree in applied mathematics. My main interests are algorithms, data structures, and artificial intelligence. So let me tell a few words about what you are going to get from this course. We are going to talk about several topics on a one-by-one basis. First of all, how to install MySQL on Windows and Mac. Then we are going to talk about the theoretical background for databases. For example, what is a database language such as SQL? What is a database server such as MySQL? We are going to talk about the data structures behind database servers, but it is absolutely crucial that if you are not interested in data structures and algorithms, then feel free to skip those lectures. So the data structures related lectures are not that crucial, but because I am interested in data structures, this is why I have included these topics as well. Then we are going to talk about table manipulation, so how to create a database table, how to insert items, remove items, update items in a database table. Then we are going to talk about the basic SQL statements such as select, where, in, between, how to use wildcards, how to define functions, how to use the order by and the group by keywords, and so on. Then we are going to talk about how to use multiple tables in a single query. So we are going to talk about foreign keys, we are going to talk about how to join multiple tables, and of course we are going to talk about database normalization. So it is very similar to architectural design and design principles in software engineering. We have to make sure that we are going to organize the database tables in the most efficient manner. So this is why we are going to talk about database normalization. Then we are going to talk about subqueries, transactions, views, indices, and constraints. We are going to talk about the data structures behind the database engines, such as what is the difference between external memory and internal memory, what is paging, what is a B tree, what is a B plus tree. Of course, again, if you are not interested in the underlying algorithms and data structures, feel free to skip those lectures because of course it is not that crucial. The last chapter is about stored procedures, so we are going to talk about how to use procedural-like scripts in MySQL, so how to create variables, how to create conditional statements, how to create loops, while loops, and so on. So these are the topics we are going to talk about on a one-by-one basis. Thanks for joining my course. Let's get started. In this chapter, we are going to talk about the theoretical background for SQL because it is going to be absolutely crucial to be able to understand the statements we are going to talk about in the coming chapters. So first of all, we have to understand what is the SQL language, and we have to understand why is it crucial to handle databases. Okay, so first of all, SQL stands for Structured Query Language. Sometimes it is pronounced as SQL, sometimes it is pronounced as SQL. Anyways, what's crucial that it was first developed back in the 1970s by IBM researchers, and it is a database language used for constructing statements processed by a database server. So first of all, we have to define what is a database language, and we have to talk about what is a database server. So first of all, let's talk about the database itself. A database is a set of persistent data used by a given application and managed by a database management system, a so-called DBMS. So the database is going to store the data we would like to store. And of course, you may pose the question that what does it mean that persistent? Persistent data means that it remains in the database permanently. And of course, it is crucial because the data in the main memory or the RAM is lost every time the application finishes execution or when we switch off the computer. So for example, if we have a calculator, for example, that's able to sum up given values, we are able to multiply given values. Of course, these values in the application is going to be lost forever whenever we close the application or whenever we switch off the computer. And of course, this is exactly why we need databases, because database is a set of persistent data, which means that it remains in the database permanently. So So no matter that we exit a given application that handles that given data, no matter we switch off the computer, a persistent data remains in the database permanently. Okay, so that's all about the database itself. Of course, we need a database management system or a so-called database server. So data present in a given database is managed by a distinct programming system, and these are called database management systems, for example, MySQL. So MySQL is a so-called DBMS, stands for Database Management System. And of course, we need a so-called database language. So every database server has a database language with which we can execute the given statements. And for example, SQL is a database language that can communicate with the MySQL database management system in order to manipulate the data in the database. So it is absolutely crucial that we are not able to use SQL to manipulate the data in the database directly. We need a so-called database management system that's going to execute the SQL statements. Of course, there are going to be several other operations under the hood. For example, MySQL is going to optimize the SQL commands. But anyways, what's crucial that the database server or the database management system will execute the database language related statements in order to manipulate the data in the database. So this is how we can visualize the process itself. We have the application. The application needs to manipulate a huge database. So for example, if we have Facebook, for example, or Twitter or LinkedIn, of course we have to store the users. And of course the users are persistent data. So for example, Facebook is going to save the user accounts into a database. So what's going to happen? I'm not sure whether Facebook is using SQL or not, but anyways, let's assume that we are using SQL as a database language. The application is going to tell the database language that, okay, you have to tell the DBMS, or the database management system, to create a new user in the database with given parameters. And by the way, we are going to talk about the data structure behind the DBMS. I'm not sure whether you are familiar with data structures or not. I am a huge fan of data structures, and this is why we are going to talk a bit about the concrete data structure behind database management systems as far as B trees and B plus trees are concerned. If you are not interested in the data structures under the hood, then of course you can skip these lectures. These lectures are totally optional. Okay, but what's crucial that the database management system stores the indices of the data in a B plus tree structure. And this is why the operations have guaranteed ordo, log, and logarithmic running time complexity. And this is why databases are quite fast. So far so good. Now we understand the three pillars of databases: the data in a database, the database management system, and the database language itself. In the next lecture, we are going to talk about the so-called relational model, and we are going to focus on SQL as the database language and MySQL as the database management system. Thanks for watching. In the previous lecture, we have been talking about database management systems and database languages, and in this lecture we are going to talk about the theoretical background of SQL as far as the relational model is concerned. So SQL is based on an abstract mathematical theory. This is the famous relational model. The relational model was first constructed back in the 1970s at IBM by E.F. Codd, and his relational model provides a theory for the database languages such as SQL. The main idea is that data is stored in tables. So SQL, of course, is a relational database language. Okay, so for example, this is a database table. So this is the basic idea behind the relational model, that we have to use a given table. Of course, you may pose the question that, are there other ways of representing the data? Of course. For example, we can represent the data as a huge graph. These are called the graph databases, such as NoSQL, and these graph-based databases are getting more and more popular popular with the advent of big data. We are going to talk about it later. What's crucial, that of course we can represent the data with the help of tables, but of course there are other techniques as well. So for example, we have to track the employees of a given company, and of course every single employee has a name, has a gender, has an age parameter, and of course there are several other parameters, but anyways, let's focus on these three parameters. Of course, we have to use some things called the primary key that's going to identify every single employee in the database. So basically every single row is going to be identified by a so-called primary key. By the way, we are going to talk about these concepts on a one-by-one basis. So we need a primary key, a unique integer basically, that's going to identify every row of the database uniquely. So as you can see, Kevin Hart has the ID 1, Joe Smith has the ID 2, then 3, 4, and 5. Okay, so we have the columns and we have the rows in a given database table, and as you can see, there may be unknown values. These are the null values. And what's crucial, that the rows in a table has no specific order. The content of the table is a set of rows basically, and this is exactly why we need the ID. So every single row is going to be identified by a given ID or a primary key, and this is how we can get the given values in a given row. So these rows are not necessarily ordered in ascending order, 1, 2, 3, 4, and so on, because the content of a table is a set of rows. There is a single value associated with a given row and a given column, and this is called the atomic value. So of course, for example, if we are dealing with the gender column, as far as the fourth row is concerned, so where the ID is equals to 4, then as you can see, there is a single atomic value male. Okay, as we have discussed earlier, unknown values are called null values, and the table must satisfy so-called integrity constraints. So for example, the age parameter should be greater than 0. This is a typical integrity constraint. And by the way, this is the database management system is going to check every time we try to manipulate a data or an atomic value in the database. And of course, every single row has a unique primary key or ID. So this is what we have been talking about, that every single row is identified by a unique integer, the so-called primary key. So we are going to talk about these concepts on a one-by-one basis. I just wanted to point it out, the fundamental basics of the relational model. Okay, and what is the main advantage of the relational model? The main advantage is that redundant data can be stored more efficiently. We can even eliminate redundancy. So every independent piece of information is located in one place, and this is called normalization. So this is the main advantage of the relational model, that we can eliminate redundancy. Okay, so in the next lecture, we are going to talk about how to store the indices of a database efficiently with the help of B-tree data structures. If you are not interested in data structures or the underlying structure of databases, then feel free to skip the next lecture. Thanks for watching. In this lecture, we are going to talk about external storage, and we are going to compare data structures with database management systems. Of course, this lecture is totally optional. It is just a theoretical background for databases. Okay, so if you are familiar with data structures such as binary search trees and balanced binary search trees, then you know that with these kinds of data structures, we can guarantee logarithmic running time complexity, which means that if we want to store, insert, and retrieve data in the most efficient manner, then we have to use a tree-like structure like this. But of course, the problem is that these data structures are stored in the main memory, so in the RAM. So what if we want to store a huge data set, for example, more than 1 GB? Then of course the problem is that we are not able to store such a huge data in the main memory. So we have no other option but to use external memory, such as file systems or databases. So as far as the internal memory or the main memory is concerned, all the data structures such as arrays, linked lists, stacks and queues, binary search trees or hash tables have something to do with the main memory, which means that we can store data efficiently with these data structures in the main memory. And of course we can use the stack memory and the heap memory when dealing with internal memory. As far as external memory is concerned, such as the hard drive disk, it can store large amounts and sizes of files such as file systems or databases. Of course, main memory is fast and external memory is slow. So this is the main disadvantage for external memory. But of course, if we have to store a lot of data, then we have no other option but to use external memory, despite the fact that it is slow. So first of all, external memory or the hard drive disk is one or more rigid, rapidly rotating platters coated with magnetic material that can retain data even when powered off. So this is what we have been talking about in one of the previous lectures, that the database is a set of persistent data used by a given application. And of course, the data in the main memory is lost every time the application finishes or we switch off the computer. So this is why we need external memory, because the hard drive disk can retain data even when powered off. So this is how we can persist data, basically. Okay, of course, there are several components of the hard drive disk, such as the track or the block. The block is a subdivision of the hard drive disk storing 512 bytes. Okay, so let's talk about the relationship between the internal memory, so the main memory, and external memory, so the hard drive disk. The data located on the hard drive disk cannot be processed explicitly. It must be brought into the main memory. In the main memory, we can use either the stack memory or the heap memory with any kinds of data structure. So what do we have to do? We have a given application, and the application is going to fetch the data from the hard drive disk. For example, when we are using a MySQL database. But the problem is that we can manipulate, so read or write the blocks, which means that at least 512 bytes. So we are not able to read just a portion of a given block present on the hard drive disk. We have to manipulate at least 512 bytes. And of course, accessing the blocks on the hard drive disk is way slower than accessing a given item in the main memory. So this is the main disadvantage for dealing with hard drive disks, such as when dealing with databases. Okay, so we can come to the conclusion that storing the data efficiently on the main memory, so in the RAM, has something to do with data structures, and organizing the data efficiently stored on the hard drive disk has something to do with database management systems or DBMSs. So this is what we have been talking about in one of the previous lectures, that database management system is a programming system that handles the data present in a given database. So for example, MySQL is a database management system. Okay, so this is the crucial difference between dealing with the main memory and dealing with external memory. Okay, so first of all, external memory is way slower. So for example, if we want to access a given item present in the external memory, it takes approximately 12 milliseconds. Accessing a given item present in the main memory takes 0.0001 milliseconds. So as you can see, the internal memory is way faster than the external memory. And of course, a database is located in the external memory. Okay, so what is the final conclusion? The final conclusion that the recursive approaches that has been working fine when dealing with data structures in the main memory are not going to work fine when dealing with data present on the external memory. When we are dealing with external memory, we have to take the access time into consideration, because this is exactly what we have been talking about. The access time as far as external memory is concerned is way larger than the access time of the internal memory. So we have to take the access time into consideration. And the second crucial difference, that when dealing with external memory, we can manipulate blocks, which means that at least 512 bytes. Okay, so finally we can come to the conclusion that we should minimize the amount of read or write operations, and this is exactly why B trees came to be, because these are shallow data structures, very similar to binary search trees, but B trees minimize the amount of read or write operations. Okay, so B-trees was first constructed back in 1971. It is a self-balancing tree-like data structure with guaranteed logarithmic running time complexity, and the basic idea is that every single node can contain multiple keys and every single node may have multiple children. Okay, so B-trees are optimized for systems that read and write large blocks of data, such as databases and file systems. Okay, so for example, this is a typical B-tree, and as you can see, the nodes can contain multiple keys and every single node may have multiple children. In this case, a given node may contain 3 keys and it can have up to 4 children. Okay, so if we store the indices of the data in a B-tree or a B plus tree, basically a B plus tree is a modified B-tree where the leaf nodes are connected in a linked list manner. So if we store the indices in a tree-like structure like this, then the logarithmic running time complexity is going to be guaranteed, and this is how we can boost up the running times for the operations as far as databases are concerned. Because of course handling data on the external memory is quite slow, but if we use proper data structures, then of course we can do a bit better. We can achieve logarithmic running time complexity with the help of B trees and B plus trees. So that's all about the data structures behind databases and database management systems. Anyways, if you are interested in these data structures, then I have a distinct course on algorithms and data structures, and you can learn a lot more on B trees and B plus trees. In the coming lectures, we are going to focus on SQL and MySQL. Thanks for watching. In this lecture, we are going to talk about the fundamental differences between procedural and non-procedural programming languages. So first of all, let's compare the two approaches. As far as procedural languages are concerned, such as C, C++, and Java, the program code is written as a sequence of commands and instructions. I'm not sure whether you are familiar with programming languages such as Java, but we can create given variables, for example, variable x, then another variable y, and we can execute given operations in a sequential manner. So for example, we can multiply these values, so x times y, and then we can print out the result. So Java is a typical procedural language where the program is written as a sequence of commands. We have to define what to do, and it is absolutely crucial that we have to define how to do that given operation. And of course, the overall efficiency of procedural languages are quite high. On the other hand, as far as functional languages, also known as non-procedural languages, are concerned, we just have to specify what to do and we don't have to specify how to do it. And this is why SQL as a non-procedural programming language is quite easy to learn, because we don't care about the underlying problems. We just want to select, for example, all the employees from the database table. We just want to calculate the sum of the age parameters and so on. We don't have to specify how we want to execute that given operation. And this is why non-procedural languages are quite easy to learn, but they are not that efficient. SQL or the Lisp programming languages are non-procedural programming languages. Okay, so we can define the methods and the variables in the procedural language. We can define conditional statements, loops, and so on. So we have full control over the application. And of course, procedural languages define the results and the entire mechanism of the application, such as with C, C++, or Java. On the other hand, with non-procedural languages, we define the query, for example, with SQL, but the database engine will do the entire mechanism. The database engine and the optimizer takes the SQL statement and decide what will be the most efficient execution. Some database vendors will enable us to write scripts such as PLSQL and TSQL, and we are going to talk about MySQL related stored procedures, so procedural commands. So this is why the database management system is quite complicated under the hood. If we have a SQL statement, then the database management system is going to take that given statement, and there's going to be several steps and phases, because there are several parts of the database management system, such as the query language processor, such as the optimizer, the database management system engine, transaction manager, and so on. And of course, these components are going to make sure that we can manipulate and update the data in the physical database with the help of extremely simple SQL statements. Anyways, that's all about the theory. I guess that you just want to learn SQL and MySQL without the underlying complicated structure. This is the crucial difference between procedural programming languages and non-procedural programming languages such as SQL. Thanks for watching. In this lecture, we are going to talk about the different types of database management systems. So there are several database management systems available out there, such as Oracle database, MS SQL, for example, MySQL, and so on. So let's talk about these database management systems on a one-by-one basis. So for example, as far as Oracle database is concerned, it uses the so-called PL/SQL language. So this is the database language, which means that PL/SQL is the database language and Oracle database is the database management system. So this is what we have been talking about in one of the previous lectures, that we can use the database language such as SQL or PL/SQL in order to communicate with the database server or the database management system such as MySQL or Oracle database in order to manipulate the data in the database. So this is exactly what's happening here as well. PL/SQL is the programming language in order to manipulate the data stored by an Oracle database. And of course, it stands for procedural language for SQL, so PL stands for procedural language. And of course, as the name suggests, it has the advantage of procedural languages. We can create loops and conditional statements, so PL/SQL is quite a powerful database language. It is quite fast and has better performance in the main. It can handle errors and exceptions, so PL/SQL is an extremely powerful database language. So as far as my experience is concerned, whenever we have developed a larger application, then we have used PL/SQL with Oracle database exclusively, because Oracle database is extremely fast and it is quite convenient. It is very similar to a procedural language with loops, conditional statements, errors and exception handling, and so on. Okay, what about MS SQL database? The MS SQL database has been constructed by Microsoft and it uses the so-called TSQL language as the database language. It has a transaction control feature. It can handle errors and exceptions as we have seen with PL/SQL. We can define variables and so on. So TSQL again is a bit more complicated database language than SQL. But of course, this is the reason why it is quite powerful as well. Of course, we have MySQL as a database management system. MySQL has a huge advantage. It is open source. It is suited for small and medium-sized web pages like WordPress websites and web pages. So for example, I have a website globalsoftwaresupport.com. This is the website itself, and these texts and images are stored in a MySQL database. So WordPress uses PHP and MySQL under the hood as far as the programming language and as far as the database management system is concerned. And of course, it is working quite fine. So MySQL is working extremely fine for small and medium-sized web pages. It cannot handle huge data sets efficiently, and transactions are not optimized in the best manner. And of course, mainly because of these reasons, it has poor performance scaling. So of course, if we have a huge application, for example, with big data, then of course MySQL is not a good choice. But if we have a very simple web page, then of course MySQL is working quite fine. Okay, what about NoSQL? NoSQL is a non-relational database system. So this is what we have been talking about in one of the previous lectures, that we can use relational databases with tables, and there are non-relational database systems. For example, graph databases. MongoDB and Apache Cassandra uses NoSQL under the hood. It is extremely useful in big data and real-time web applications where we have to manipulate a huge amount of data. And of course, it has a huge advantage. It is massively scalable. So this is why NoSQL is getting more and more popular with the advent of big data and real-time web applications. So these are the different types of database management systems and database languages. Of course, we are going to focus on SQL and MySQL. Thanks for watching.